Hi, my name is Samuel Mujisha. I am a data scientist specializing in building end-to-end machine learning solutions. Today, I'm excited to share with you this project, enhancing marketing campaigns using AI-powered insights. This is a common marketing challenge, and I hope you enjoy this project as I take you through the different steps on how I built it. I'll share with you the executive summary, the business problem in detail, take you through the exploratory data analysis results, take through the feature engineering techniques that were used, the model building and performance summary, the deployment or the demo of the model, and then there's a part two where I'll take you through the clustering algorithms that were used and business recommendations and lessons and conclusions learned. So in summary, I have developed, tested, and deployed an end-to-end machine learning solution. I developed several models. The XGBoost model was the best with an F1 score of 89.27% and the precision recall area under the curve of 91.88%. We're able to profile 3 or 4 subscriber segments using k-means clustering techniques, and also suggested a number of business recommendations that the bank would use to optimize their marketing programs. So the client is a European bank. The bank has a number of products. Key here is the term deposit product, which is a short-term deposit with maturities ranging from 1 month to a few years. The marketing department calls customers multiple times to get a subscription. So the data that we have is a call center data of 4,000 calls, and this is real-time data that was obtained from this bank by AppZiva, and I did this project as part of my AppZiva AI residence program. So looking at the data, we have data about the customers. This is call center data. We have the age, the job, the marital status, the education, if the customer has defaulted on a loan, the balance on the loan, if they have a housing loan or a personal loan, the contact method used, the day of the month when the calls were made, the month when the calls were made, the duration of the calls, and the number of times the calls were made during the campaign program, and the target variable Y, which has whether the customer subscribed or not. So this is really the marketing mix challenge that we have to deal with. We have characteristics about who the customer is, the age, the job, the marital status, the education, when the contact was made, the month and day, and whether and the what, the default, where they have a default on previous loans, the housing loan, personal loan, etc., and how the contact was made, whether by phone, the number of calls, and the duration of those calls. And these key characteristics are very, very key for any marketing challenge to understand what is exactly the persona to call, when is the best time to call them, what are the characteristics of this persona, and how, what is the best way to contact them, be able to get a successful subscription. So a quick data analysis showed that our data is heavily imbalanced. The yes class is only 72.72%. So the data is heavily balanced, and therefore we have to apply some techniques to be able to balance the data and obtain a sensible model. Further exploratory data analysis revealed that most subscriptions come from customers with tertiary education. Students and retired workers subscribe more. Customers who subscribe tend to have a slightly broader age distribution. We see a peak in the ages of the late 20s and early 30s, but customers subscribe even in their late ages above 60. So age is widely distributed for all the different customers. Another analysis showed that most subscriptions happen in October, March, and April. Those are the peak months for subscriptions. We also found out that the first day and 30th day of the month are the most days for subscriptions to happen. So again, very, very key to focus on those dates. Looking at the duration, we found that longer contact durations are significantly associated with a yes subscription. So it's very important that you have this a good call with the customer. If the call is very short, then they are most not likely going to subscribe. Looking at the campaign, we found that there is an inverse relationship between number of calls and subscriptions. That is, the more customers were called, the more they were less likely to subscribe, and this is very key as well to understand for the marketing team. Cellular contact yields more subscription. However, we have the unknown contact method that needs to be improved in the later data collection to make sure that it is known of the unknown contact that is not known that we need to make known. The heat map of numerical variables, we saw that there is no strong correlations, and therefore we have challenges of multicollinearity that we may need to deal with in this data set. So in summary, the exploratory data analysis showed us who customers to target, where to target them, and how to target them. We now know that the bank needs to focus their efforts with customers with tertiary education, students, and retired workers. We know that the best time to run marketing campaign is October, March, April, and the best days are the first and last day of the month. And the marketing team has to aim for long contract durations and avoid very many attempts, as these are associated with lack of subscription. So we now move on to the next. We now did data preprocessing, and there are different data preprocessing techniques that we had to apply to get to a very good data set. First, the categorical variables: job, marital, education, contact, and month were one-hot encoded to convert them to numerical variables without introducing any artificial order, and this worked very well. Then the other variables that had no or yes values were binary encoded to get 0 or 1 values. All numerical values were encoded using standard scalar, and we applied the random undersampler to address the heavy class imbalance. So we started building our model, but before we went deep, we had to understand which metrics are very important. So we have two scenarios here that are key for us to understand. Number one is if a customer is predicted to subscribe, but in reality does not, or the customer is predicted not to subscribe, but in reality does. Both cases are important. In my view, predicting that the customer will not subscribe, but they do, results into a greater loss because the potential customer is missed. But both cases are very, very important. So it's best to look at the F1 score, the harmonic mean of precision and recall and accuracy, so that we can get a balanced score in this case. Also to look at the precision recall area under the curve, since the data is imbalanced, to get a good trade-off between the precision and the recall. So we trained 5 different models: the logistic regression model, the k-nearest neighbors model, the decision tree classifier, the random forest classifier, and the XGBoost classifier. These models were trained using 5-fold stratification, and the models were tuned using grid search CV, and we obtained, at the end of all this training, we obtained the XGBoost with the highest F1 score of 89.19% and a high accuracy of 89.01%. Further analysis of the area under the curve for precision and recall, the XGBoost model performed the best with a 91.88% area under the curve, again outperforming the other models, showing that the model really is achieving great balance of precision and recall for all thresholds. So we did further model tuning of XGBoost using the optimal threshold. The default is 0.5. Our optimal threshold was found at 0.52. And once tuning the model with this optimal threshold, the model marginally improved with a better F1 score and accuracy, and a slight decrease in recall, which means the model is performing well, especially in the real-world marketing scenario, making sure that the subscribers that we need to target are targeted well. So we can now do some business cost calculation to really understand what is the really investment case, what is the cost of deploying such a model. And we can do this by looking at the cost of false positives, where we get the false positive from our decision matrix, our confusion matrix, multiply by the cost, and look at the cost of false negatives, again by getting the value from our confusion matrix of false negatives and multiplying this by the cost of the false negatives. Assuming the cost of a false positive of $100 and the cost of a false negative over $1,000, we can get the business cost of implementing our model. Now, using the same technique, we can find the cost of not implementing the model, or baseline cost without the model, using the same formula, and we have used some numbers here. If we didn't have the model, how many false positive would we get? And we have assumed a number there, but we would have to get the real values from the bank and use this. But using these assumption numbers, we can say the model can actually uncover a lot of savings for the bank. So the model saves money by more accurately identifying potential subscribers, thereby reducing the instances of both wasted marketing spend and lost revenue opportunities. The extent of the savings will depend on the cost of the false positives and the false negatives. So this model has a huge potential to save money for the bank. In terms of our deployment, we move now to deploy the model on Hugging Face. The model was saved using JobLib. We used Docker for containerization, used the Flask REST API for predictions, and Streamlit UI for user interactions. I'll now show you a quick demo of the model deployed on Hugging Face. Have a look. We have the back end. The front end and the back end are decoupled, so we have the back end separate, very good for flexibility and maintainability. So the back end is here waiting for predictions, and we have the front end where we can quickly see the interface that has been designed that our users can use to access to make predictions. So using this data, for instance, here, we can make a prediction. When you click predict subscription, the model will run and show us the results. I will repeat this. Oh, the customer will likely subscribe. Okay, let's reduce the call duration, for instance, to 40 seconds and see. Oh, the customer will likely not subscribe. Let us see what if we go to the peak period of the call. It's in October and the duration is still 40. We predict the customer will not subscribe. Let me increase the duration once again to 100 and see the customer will subscribe. So really the last contact duration is very, very key. But we can use this model. The bank can use this interface to interact with the model and make decisions before spending money on a call, etc, etc. So the model is now deployed on Hugging Face and is ready for use. Now we did a part 2 where we try to do marketing segmentation, which is very, very key, again, for marketing teams to understand the profiles of each of the sectors that they are targeting. And we did this. It's an unsupervised learning, machine learning technique. We prepared the data, go to the right subscriber selection, did data scaling, applied K-means clustering, used the T-distributed stochastic neighbor embedding technique to visualize our clusters and did interpretation of these clusters. Let's go deeper and see how this worked. So again, we did some data preparation. We did one-hot encoding and converted Boolean columns to integers. The target variable was converted to numeric 0, 1. Subscriber selection, we selected all subscribers that subscribed yes, and we remained with the data set of rows that we will use for this unsupervised learning challenge. We scaled all numerical data using standard scaler, very, very key, especially before we can do any clustering. Yeah, we do clustering, we have to find the optimal number of clusters, and using the elbow method, we found the optimal number of clusters to be around 3 or 4. That's where the curve begins to make a noticeable bend. So we have 3 clusters that were identified and visualized using this TSNE. And we profile these clusters, and for the 12 clusters, really, we have the affluent educated professionals. These have high balance on their accounts, have high education, and have low debt. We have the middle income home owners. They have moderate balance on their accounts, have blue collar admin jobs, have secondary education, and have higher housing loan propensity. And cluster number 2, financially strained borrowers. These have a negative balance, history of default, high likelihood of both housing and personal loans. Using 4 clusters and visualizing this with TNSE, we can again see 4 clusters here. And the clusters are almost similar to when K was 3, but the difference now is that the middle class has been broken into 2. We have the middle income home owners who have higher propensity for housing loans, and the working class borrowers who have lower balances and have higher propensity for personal loans without necessarily having been defaulted. So depending on the banking depth that they want to achieve with the marketing team, you could potentially cluster the segments of marketing into 4 or 3. Yeah, and now the bank adopt different marketing strategies for different clusters. For instance, for the affluent professionals, we can use a premium strategy, use wealth and management exclusive products, use personalized advice, use relationship managers, use channels such as the digital thought leadership, private banking, and encourage and use slogans like grow and preserve wealth with exclusive access. This is for cluster 0, the affluent professionals. But for the financial strained borrowers, again, different products can be targeted for them: debt consolidation, credit rebuilding, financial literacy, etc. And you can access these through simple and accessible SMS or mobile, and use marketing campaigns with slogans like "We help you recover and rebuild financially." So over to you, marketing teams. You can now use the clusters and adopt your own marketing strategies. These are mine for you to adopt if you like. So in summary, we've used several tech techniques. The key was to handle class imbalance to make sure that the model is not biased towards the majority class. Scale numerical features, key to work. Do hyperparameter tuning to reduce overfitting and improve generalization. Do threshold optimization to improve the balance between recall and precision. Evaluate tuned models. Do clustering and analyze business implications. This project requires very many skills: supervised and supervised machine learning techniques, Python and scikit-learn, data analysis and visualization, feature engineering, model development, tuning and evaluation, API development with Flask, UI development with Streamlit, Docker and deployment. Really end-to-end machine learning skills. So in summary, the bank now has a model that they can use to adopt for marketing campaigns. This model will help the bank to maximize conversions by targeting high potential customers, reduce marketing waste by avoiding low probability prospects, and improve return on investment across campaign efforts. 3 high-value customer segments have been identified: affluent education professionals, middle-income homeowners, and financially strained borrowers. Each segment requires tailored marketing strategy in terms of messaging, product positions, etc. Key: the bank needs to focus on the quality of calls. Marketing agents should ensure to get a preferred time and have a good call with clients. Focus on key months, October, March, and April, which are peak, and expand the target base to students and retirees. I hope you enjoyed this project. I did. It was quite challenging, but I went deep and uncovered enormous insights that any banking institution could use. If you would like me to do similar analysis for your data, please don't hesitate to contact me on LinkedIn. That is my address. Thank you very much.